Hi everyone, today we're going to go over how to graph quadratic equations when they're in standard form. So the key to this is that all of the equations we're going to look at, we're going to make sure they're in standard form. Next week you're going to look at vertex form, but what we're looking at today is standard form. To review, standard form looks like ax squared plus bx plus c. In other words, all of your variables and your constants are on one side of the equal sign. Sometimes your quadratic will be set equal to 0. Other times you may see it set equal to y. And if it's in function notation, you'll see that it's set equal to f of x. If your quadratic equation is not in standard form and it has a constant on the opposite side of the equal sign, or it has a variable on the opposite side of the equal sign, make sure you put it into standard form before you get started. If you don't, you will not get the correct answer. All right, so let's look at our first problem and get started. We're going to go through 5 steps that are going to take you from the equation to the graph. All right, looking at this equation, number 1, y equals 2x squared minus 4x minus 6. First thing that you want to do is you want to write down a, b, and c. A is the coefficient to x squared. B is the coefficient to your regular x. And then c is your constant. So we're going to write these down in our graphic organizer so that we can refer to them as we go through each of our steps. So a is 2, and it's positive. B is negative 4. C is negative 6. All right, now step 1. You're going to circle, or if you don't have a graphic organizer, you're just going to write this down. The parabola opens up or it opens down. So we're trying to figure out, what does this parabola look like? And the way that we figure this out is by looking at our a value. All right, so this is all about the a value in step 1. Your a value is going to tell you if it opens up or opens down. When we say opens up, we mean a parabola that looks like this, like a regular U. Opening down looks like an upside down U or an N. If it is a positive a value, that's when your parabola opens up. And if it's a negative a value, that's when your parabola opens down. So in this one, since we have a positive 2 as our a value, we are going to have our parabola open up. It's going to look like this. So that's the first step. We've decided that our parabola looks like it's opening up like a regular U. Let's move on and find out some other key features of this graph. 2, find the axis of symmetry. Now to refresh what the axis of symmetry is, okay, since we know our parabola looks like a U, our axis of symmetry is an invisible line that cuts our parabola in half, and it passes through the vertex of our parabola. And we also know that any point on the parabola has an equal reflected point on the other side of the axis of symmetry. So that's what we're going to be solving for right now. We're going to be solving for this imaginary blue line that's going to cut through the vertex of our parabola. So to figure out the axis of symmetry, you're going to get x equals, which is the equation for that vertical line. It's in an x equals format. It's x equals negative b over 2a. So all we have to do is we have to plug in to this little equation. So let's get started. Negative b, so negative, and then our b value is negative 4, all over 2, and then our a value is 2. Okay, simplifying this a little bit further. Negative 4 gives us a positive 4 all over 2 times 2, which is 4 again. 4 divided by 4 is 1. So that means that this equation for this vertical line on our parabola is x equals 1. That also means that the vertex of our parabola has an x value that is 1. In our next step, step 3, we're going to find the y value of this vertex. Now, how do we find the vertex? Well, we know that the x value is 1, and to find the y value, we're just going to plug in 1 for our x value back into the quadratic equation and see what the output is. So let's go ahead and do that. So I'm going to use function notation in this example because I want to make sure that you see that the quadratic equation can have a y value that it's set equal to, or it could say f of x. So I'm going to do f of 1 because we're plugging in 1 into our quadratic equation. 2 parentheses 1 squared minus 4 times 1 minus 6. Okay, let's go to the next step, start evaluating this. So I'm going to do, 1 second. I'm going to do the 1 squared first. So 1 squared is 1. Minus 4 times 1, so that's minus 4. And then minus 6. Next step, I'm going to multiply 2 times 1, so 2 minus 4 minus 6. 2 minus 4 is negative 2. Minus 6 is negative 8. So our y value, or f of 1, our output when we put in 1 as our x value, is going to be negative 8. So that means that this vertex for our parabola is going to be at negative 8. So we already have a couple of things that we know about our parabola. We know that it is facing up, it opens up, and we know that the vertex of our parabola is at 1, negative 8. Let's keep going. The next question we're going to ask ourselves is, with our parabola, is the vertex a maximum or a minimum? Now take a look at your parabola. If it's a U shape, the vertex down here, 1 second, I erased it. The vertex down here is at the bottom of the parabola. It looks like it's the lowest point on your parabola. So it's going to be a minimum. Anytime that you have a positive a value, meaning that your parabola opens up, it's going to be a minimum for that vertex point. All right, let's go on to step 4, which is finding the y-intercept. Step 4, when you find the y-intercept, all you're looking for is c, your c value, your constant. It's a very easy thing to do. So I'm going to go ahead and take a look at my equation and see what is the c value. Our c value is negative 6. So that means that your y-intercept is negative 6. It's going to cross the y-axis at negative 6. So I'm going to say down here my c is equal to negative 6. So my y-intercept, if I write it as a coordinate, is at 0, negative 6. Now, so that you can see kind of a graph here as to what that would look like. On a graph, that means that my parabola is crossing through negative 6 on the y-axis. So that's another key feature of this graph. Now, here's a little note that I want you to mention, or rather want you to notice. When graphing, after we have our y-intercept, we can reflect the y-intercept over the axis of symmetry to get another point. So the fact that we have this y-intercept and that we have our axis of symmetry already, as soon as I have those two things graphed, so imagine this is where our axis of symmetry is, we can reflect that point over the axis of symmetry. So if it's, let's say, 1 box away, we count 1 box away on the other side, and then we would plot another point. So we have a lot of different points that we can start plotting here to start visualizing our graph. There's one more thing that we're going to do. So far, it's been pretty easy figuring everything out. The last step before we're going to start graphing is the hardest step. It's what we've been doing in our previous topics, which is factoring or using the quadratic formula. And that's right. What we're going to be doing is we're going to be finding the x-intercepts. The x-intercepts are also known as the roots of the parabola. They're also known as the solutions to the parabola. Okay? So you have two options on how you can find those x-intercepts. You're either going to use the quadratic formula, or you could factor. And then once you factored, you set each factor equal to 0. So it's whatever you choose. Maybe you're more comfortable using the quadratic formula each and every time. Maybe you're really good at factoring and you want to stick to factoring. You do what you know is your strength. And you're going to make sure that that's what you utilize in order to figure out your x-intercepts. Now, sometimes you may start factoring, for example, and you realize you can't factor what's happening there. That could be that you either have a very difficult quadratic that you're trying to factor, and maybe you want to try the quadratic formula, or it could mean that you do not have any real roots, and your parabola will not cross the x-axis, so it won't have any x-intercepts. Let's take a look at this particular equation, and let's figure out how we're going to factor this one. So I'm going to use the factoring method in order to come up with our x-intercepts. So step one, I'm going to write down our quadratic equation. All right, so our equation is y equals 2x squared minus 4x minus 6. Now, the first step whenever you factor is to see if there's a greatest common factor that you can factor out before you get started. If you can factor something out, it's going to make all of the future factoring much easier. So I notice that in this equation, 2, let me fix that, 2, -4, and -6 do have a factor. They can all be divisible by 2. So before I even get started, I'm going to factor out a 2, and everything is going to get much smaller in terms of the values that I'm working with. So factoring is going to be a lot easier. So if I factor out a 2, for the first part, I'm going to be left with x squared. If I take -4 and I divide out a 2, I'm going to have -2x. And then the last piece, -6, if I factor out a 2, I'm left with -3. Okay, and this is now going to be what we factor. So we're going to look at what's inside of our parentheses. Now remember, we're going to look at, we're going to look at two things that multiply to be -3, but add to be -2. So I'm going to write down the different factors that I can come up with for -3. So for -3, all I really have is 3 and 1. So I have 3 and 1. Since -3 is what we're looking at for our C value, one of these is going to have to be positive and one of them is going to have to be negative. So if I make the 1 negative, I'm going to write down the other factors again, 3 and 1, and now I'm going to make the 3 negative. And I'm going to see which of these factors is going to give me -2. Well, looking at the first one, 3 minus 1 is going to give me 2. That's not what I want. I don't want 2. I want -2. So again, let's look at the next one. -3 plus 1, that gives me -2. That's exactly what I want. So these are going to be the factors that I use when I start setting up my 2 bubbles. So now going the next step, 2, set up my 2 parentheses, all right, my 2 bubbles. Now I'm going to have x in each box, -3 plus 1. Now the last step, because now this is factored, the last step to find the actual x-intercepts, to find the roots, to find the solutions, is you're going to set this equal to 0. So instead of having y, it's going to be equal to 0. Because we're looking at where the parabola is going to cross the x-axis. And when you're on the x-axis, your y value is 0. So now, next step, each of these 2 factors is going to be set equal to 0. In fact, all 3 pieces of this are going to be set equal to 0. 2 can't equal 0, so this isn't going to give you anything good. The next piece, you're going to set x minus 3 equal to 0, and then x plus 1 equal to 0. Add 3 to both sides. So now we have x equals 3. That's one of our solutions. That's one of our x-intercepts. Now for the other one. Subtract 1 from both sides. And now x equals negative 1. So our x-intercepts are going to be at negative 1 and at 3. I put it in these curly brackets, but another way to look at your x-intercept is you have an x-intercept at negative 1 comma 0, and you have an x-intercept at 3 comma 0. That's where it's going to cross the x-axis. All right, now let's put all of this together and let's graph our quadratic equation. Okay, so first thing we're going to do is we're going to graph our axis of symmetry. Now, we saw before our axis of symmetry is at x equals 1. It's a vertical line passing through 1 on the x-axis. So that's the first thing I'm going to go ahead and I'm going to graph. And I know that my parabola is going to have its vertex somewhere along this axis of symmetry. All right, so now the next thing I'm going to do is I'm going to plot my vertex. And my vertex we saw was at 1 comma negative 8. Okay, so I'm going to change my color and I'm going to go to 1, negative 8 and plot a point right there. So I know that's going to be my vertex, my minimum. Now the next thing that I'm going to do is I'm going to go ahead and I'm going to plot my y-intercept. Okay, so my y-intercept is at negative 6. We saw that in step 4. So my y-intercept, I'm going to plot right there. And remember the little note. When graphing, reflect this point over the axis of symmetry to get another point. So looking at my y-intercept, I plotted at negative 4. Give me 1 second. Let me fix that. It should be at negative 6. Okay, here we go. So once I've plotted this negative 6, I want to reflect it over this line. I'm 1 box away from the axis of symmetry. So I'm going to go again 1 box on the other side. And so here's another point that has to be on our parabola. Okay, now the last important pieces of information that I figured out were where the x-intercepts are, where the roots are. So our roots are at negative 1 and at 3. So I'm going to plot a point at negative 1. I'm going to plot another point at 3. And now you want to connect all of these points because you see it's kind of a U shape already. It kind of looks like a U. It looks like a very skinny U, but we kind of see exactly where our parabola is. So let's go ahead and we're going to connect these points. Okay, so try your best to try and make it curved. I don't know how good this is going to turn out, but okay, so that's our parabola. I'm going to include my arrows on either side to show that it continues infinitely, to the left, to the right, and upwards. Now, before we move on to the next question, I want to ask you 2 things and bring back the concept of domain and range. So for the domain, almost every single parabola you're going to deal with, unless it's in a real world situation, if we're just looking at an equation, is going to have all real numbers as its domain. Remember this end behavior right here? This end behavior right here says that your parabola continues infinitely. It goes up, but it also goes a little bit to the left each and every time. Same thing with the right arrow. It goes up and it goes to the right each and every time. So it's going to continue. So your domain, really, it's going to cover everything from right to left, from left to right. So your domain is all real numbers. Now for your range is your y values. Now looking at this graph, we have a minimum. The very minimum that you have here is at negative 8 on your y-axis. So negative 8 is the lowest that your y value is going to be. But notice that the graph continues going up. So I just need to go ahead and I need to write some type of inequality that says the lowest that my y value is going to be is negative 8, but I can have anything that goes above negative 8. And the way that we're going to write that is we're going to write y. Ooh, I don't want to write it in that highlighter. We're going to write y is greater than or equal to -8. And that's our domain and our range. So notice most of the time your domain is going to be all real numbers, but your range will change. It all depends on where the vertex is. And it's either going to go above that point or below that point, depending on if it's an up-facing parabola or a down-facing parabola. Okay, let's go on to the next question.